All right, guys, welcome to lesson 4. Now we're actually starting to get into the algebra topics, the college algebra topics. And so far we've been dealing with expressions. And expressions, they don't have an equal sign. An equation does have an equal sign. And so here we're going to be talking about linear and rational equations. So an equation is a statement that sets two expressions, which we've already talked about in previous sections, that are equal. So you have x plus 2 equals 9, 11x plus 5x plus 6x, and so on and so forth. Those are examples of equations. To solve an equation means to find all numbers that make that equation a true statement, which can be referred to as solutions, roots of the equations. The solutions of an equation make up its solution set. So a lot of times you might be asked to write your answer as a solution set. You might be asked to write your answers as a solution set, and I'm going to show you how to do that. Equations with the same solution sets are equivalent expressions. So x equals 4, x plus 1 equals 5, and 6x plus 3 equals 27. These are all the same. They have a solution of 4. So you use your braces and you say, what is your solution? And so in this case, your solution set is 4. All right, you have x squared plus 9 equals 9 and x equals 3. These are not equivalent because when you take the square root of 9, you end up with both a positive and negative of 3. And this only gives you 1, so these are not equivalent. Okay, so the golden rule of algebra is whatever you do to one side, you must do to the other. A linear equation in one variable is an equation of the form ax plus b equals 0, also known as a first degree equation. All right, you may be asked to find out, is it a linear equation or not? And they just give you the expression. All right, you're looking for something that fits this form, where x is only raised to the first power. If it's raised to a higher power or a lesser power, it's not linear. It has to be raised to only 1. Okay, so on A, 3x plus 5, x is raised to the first power, so that's easy. Yes, it is a linear equation. 2, or B, you have x times x. When you do x times x, you end up with x squared. That's higher than 1, so this is not a linear equation. You could work this out, but this would be 8x plus 2 equals 3 minus 2x minus 4. So I didn't multiply x times x like I did on B. So even when I move this across the equal sign, my x is not going to be higher than, it's not going to be raised to higher than 1 power. So this is going to be a linear equation. Now you can continue to simplify it if you wanted to, but it will be. Now on D, I'm going to divide the 3, and so that's going to be the square root of x minus 1 equals 2. Now we've already talked about rational expressions, rational exponents, where you can take any root and write it in terms of a exponent. So I could say x minus 1 to the 1/2 equals 2. Well, that's a problem because that is not a linear function. X raised to the 1/2, like I said, it has to be exactly 1. If it's higher or lower than 1, it's not linear. So this is not linear. Okay, so the bulk of what you'll be doing in this class and going forward in other classes is, can you solve linear equation? So on number 1 here, I'm going to distribute the 3 and the negative and move everything up and solve for x. So this is going to be 6x minus 12 equals 7 minus x minus 5. All right, clean up the right side. So we get 6x minus 12 equals negative x plus 2. Now, what you're going to do here is you're going to add x to both sides, because you got to get all your x's to the same side. And remember, whatever you do to one side, you do to the other. And if you're moving across the equal sign, you have to change the sign of what you're working with. So it was negative, now I made it positive, so that's going to be 7x minus 12 equals 2. And then I'm going to add the 12 to both sides. It was negative, now it's positive. So you got 7x equals 14. And then you're going to divide the 7 from both sides to get x by itself. And so x equals 2. Now, as you get more and more comfortable with this, you don't have to show all the extra steps that I did in purple, but do that until you feel comfortable. On number 2, do the same thing. Negative 4 times 3, that's going to be negative 12x. All right, 2 negatives make a positive, so it's going to be 20 equals 3 minus 8x minus 7. Let's clean this up. Equals negative 8x minus 4. All right, both sides are negative, so you can just get in the habit of moving everything to the left, all your x's to the left, so it reads x equals something when you're done. Or I'm going to move the 12x, and so that's going to be 20 equals 12x minus 8x is going to be 4x minus 4. So it's going to be 24 equals 4x. 6 equals x. So there you go. Number 3, we have 18x minus 6 equals 8 minus 10x plus 14. All right, so you got 18x minus 6 equals negative 10x plus 22. That's going to be 28x minus 6 equals 22. 28x equals 28. X equals 1. All right, what about fractions? Well, the great thing about this is because of the equal sign, I can actually do this thing called fraction busting. So I can't add or subtract fractions unless I know the common denominator. All right, between 3, 2, and 4, my common denominator would be 12. But instead of finding the common denominator and working with fractions, I can take what would be my common denominator, 12, and multiply every term by that, and that gets rid of my fractions. And whether you work with fractions or you get rid of the fractions like I'm doing here, you get the same answer. So I'll let you be the judge of what you want to do, but I'm going to finish showing you how to do this. So 3 goes into 12 4 times. So this first fraction is going to be 4 times 2x plus 4. Plus half of 12 is 6, so that's going to be 6x. 4 goes into 12 3 times. 3 times 1 is 1. So, 3 times 3 times 1 is 3. So I got 3x minus 3 goes into 12 4 times 7 is 28. So just like that, I don't have any fractions anymore. I just need to clean it up, solve for x. This is going to be 8x plus 16 plus 6x equals 3x minus 28. That's going to be 14x plus 16 equals 3x minus 28. That's going to be 11x plus 16 equals negative 28. 11x equals, this should be, when you subtract, this is going to be negative 44. X equals negative 4. There you go. Now, if you ever get to an answer and you're questioning, is this actually right or not? So like in the 1, 2, and 3, all the answers were positive whole numbers. This one was our first negative. What if it's a fraction? What if it's a decimal? All right, if you're concerned about it, plug it back in and see if it works. All right, that's a great way to check your work. But just because it's not positive and just because it's a fraction doesn't mean it's not the right answer. I know a lot of students struggle with that, but it's okay. Okay, number 5, my common denominator. Let's see, I got 10, 2, 5. 2 and 5 go into 10, so 10 would be my common denominator, so let's multiply. All right, because 10 is my first denominator, those are just going to cancel, and I'm left with 3x plus 6. Minus half of 10 is 5, so I got 5x here. 5 goes into 10 2 times. 2 times 2 is 4, so I got 4x. Plus 5 times 2, 5 goes into 10 2 times. 2 times 33 is 66. All right, so let's clean this up. That's going to be negative 2x plus 6 equals 4x plus 66. All right, that's going to be 6 equals 6x plus 66. Subtract, you get 60, or negative 60 rather. 6x, and then negative 10 equals x. All right. Now, rational expressions. We've kind of already talked about this. but same thing. I'm going to get rid of the fractions. And this time, it becomes a rational expression and not just a fraction when there's variables in the bottom. So not only do we need to consider the domain, but we also need to actually solve for what x is. Okay, so my domain here, if you set x or 2x equal to 0, it breaks it. So I can't let x be 0. So my domain is everything but 0. Okay, now with that said, let's work this. So x goes into 10x 10 times, so 10 times 1 is 10. 5 goes into 10x 2x times, so 2x. And then 2x goes into 10x 5 times, so it's going to be plus 15. And just like that, I got rid of the fractions. Okay, and so that's going to be negative 5 equals 2x equals negative 5 over 2. So here, I got a fraction as an answer, and if you don't like it, plug it back in and see if it works. 5 halves is 2.5, so if you'd rather work with a fraction or work with the decimal, you can. But negative 2.5, plug it in and see if it works. All right, so here we have x minus 3 equals 0. So x equals 3. So my domain is not positive 3. Okay, but I'm going to take that x minus 3 and I'll multiply the whole thing to get rid of the fractions. So it's going to be x equals 3 plus 9 times x minus 3. Okay, so that's going to be x equals 3 plus 9x minus 27. So it's going to be negative 8x equals negative 24. X equals positive 3. Okay, now the problem with this is we just found that 3 was not my domain. So this actually doesn't work at all. The only thing that the algebra gave me was something that I can't use. So the actual answer is no solution. In short, the proposed solution was not in the domain. Okay, so I have to throw it out, and my answer is no solution. Okay, so there are types of equations that we want to that you need to be familiar with. All right, so let's solve this first one here. So we end up with, let's see, we got negative 2x minus 8 plus 3x equals x minus 8. All right, so 3x minus 2x is going to be x minus 8. You already may be thinking of what's about to happen. If I move one of the x's, I end up with negative 8 equals negative 8. Well, that is a true statement. And if I end up with a true statement, like the x's fall out, and I'm just left with something that's true, this is what we call an identity. And that means my answer is going to be all real numbers. Okay. On number 5, not 5, on number 8, we got 5x equals 15, x equals 3. So it actually equals something. Okay, this is what we call conditional. It works for one solution, so it depends on the conditions you're given. It works for one solution. 7 works anytime. 8 works some of the time, and it gives you a specific answer. All right, so look at number 9. All right, so this gives me 9x minus 3 equals 9x plus 7. Well, you have 9x on both sides, so if you move 1, you end up with negative 3 equals positive 7. That does not work. So this is what we call a contradiction. This is what we call a contradiction, and I would write that as no solution or an empty set. Okay? Now, another thing that they may ask you to do is if you, with equations, you can't solve for anything in particular. You can't solve for an answer if you have more than one variable. But if you have more than one variable, you can manipulate the problem to solve for a particular variable. So for this first problem, you have your simple interest formula, I equals PRT, and it says go find the equation for T. Well, in that situation, I would just simply divide by everything that's not t. And my answer would be I equal I over PR equals t. Okay. Here you have your compound you have another interest formula, and it says solve for p. But I got p's on both sides of the equal sign, so I need to get them on the same side first. So a equals p plus p RT. Once they're on the same side, you can take a GCF. So you get a equals p times 1 plus RT. All right. P was one of my terms. It was also my GCF. Anytime a GCF is one of your terms, you have to replace it with 1. Okay, so now that I have P by itself, I divide by everything that's not P. So this is going to be A over 1 plus RT equals P. All right? And then here, we're solving for x. There's x on both sides, so I need to do a little bit of solving. So this is going to be 6x minus 15a plus 4b equals 4x minus 2. Okay, I'm going to get all my x's to the left and everything else to the right. So this is going to be 2x equals positive 15a minus 4b all over 2, or minus 2, and then I'm going to divide 15a minus 4b minus 2 over 2. Okay, so that's how you do it. You can, if you have more than one variable, you can solve for a particular variable, but you can't get an actual answer. But if you were trying to solve for something, it may save you some time instead of trying to manipulate things after the fact. So that is lesson 4. I'll see you in the next lesson.